Hi everyone, good morning, or good afternoon, or good evening, depending on when you're watching this. So today we'll be looking at Matplotlib. We have looked at pandas, we have looked at Numpy, we have looked at pandas. So now we're looking at Matplotlib. Now, Matplotlib is a library for visualizing charts, yeah, especially numeric charts, either X or Y axis. So we use it to carry out plots, either graph or either line chart, bar chart, or different kind of charts. Okay, but it's mostly a line chart. Okay, so now let's look at so Matplotlib. You could visit their website here, or you could come under help and navigate to the Matplotlib reference and click here. Okay, so I'm going to wait for it to load. Okay, so now this is the Matplotlib website. Okay, so you could get started, you get examples, you get reference, you get cheat sheet, you get documentations. Okay, for this we just want to navigate through, let's see, examples. Okay, now for the examples we can see the basics of charts. We have wave chart, we have scatter, we have bar, we have fill in between, we have step, we have stem. So now these are different kind of plots. Okay, different kind of plots, statistical plots. You could have bar, arrow bar, Pauling, pi, x beam. There are different kind of plots. So if, for example, if I want to explore, let's say I want to use an histogram, I could try this out. So the word they use here is ax.ist. We'll be looking at it later. So let's just dive into the library, into the beginning of the library. So the first thing first is to run Matplotlib. Okay. So most data visualization has to do with representing uncertainty of data. Okay. So if you're not sure of the data, you could represent it, you could visualize it to see the outlook or the outcome of the chart. Or yeah. So now let's run using Shift Enter to run. So import matplotlib.py plus as PLT. Then we import Cbon. We haven't done Cbon yet, but that's the next thing we are looking at the moment we finish this library. So now Matplotlib inline. Matplotlib inline is just to allow to allow the compiler or the interpreter of this library, that's Python, to oversee overlapping of charts. Let's say a chart is overlapping another, or so the end goal is just to help properly fix the chart. So this is usually common in Python too, but now there's no need for doing Matplotlib inline in Python 3. We are using Python 3 here. Okay, there's no need, but I just have it there. Okay, so moving on, the next thing to do, we're going to import Numpy. So now we've worked with Numpy. If you're familiar with Numpy, that's good to hear. That's great. If you don't know what Numpy is, please kindly go back to our previous videos. Okay, so we've talked about Numpy. We import Numpy as NP. Now, don't forget I told us that Matplotlib is used to visualize mathematical or numeric charts or graph. So now we have x, y. So x equals to np plus linspace. Now, linspace means give me a range between 1 to 10 of size 6. Okay, so that is giving the value between 1 to 10 of size 6. Okay, so if I run this, and if I say y equals to x raised to power of 2, that is the value of x here raised to power of 2. So now let's take it one after the other. So if I print x, let me run this first. If I print x, I have 1, 2, 4, 6, 8 there. Now let me change this 6 to 2. So it's going to give us a size of what? X is going to be size of 2, that's 1 and 10. If I change this to 3, it's going to give me a size of three, just three numbers, 1, 5, 10. Now these numbers are constant, they don't change. Okay, they don't change. So if I say give me size of 5, it's going to give me 5 numbers from range of 1 to 10. If I say from range of 1 to 11, it's going to give me 5 numbers from 1 to 11. Okay, so when we talk about, when we say y equals to x to the power of 2, that is the value, this value raised to the power of 2. So 1 raised to the power of 1 is 1, 3 raised to the power of 2. Let me run this, I haven't run this yet. So 3 raised to the power of 2 is 9, 6 raised to the power of 2 36, 8 raised to the power of 2 64, 11 raised to the power of 2 121. Okay, now don't forget we talked about numpy, and we said numpy is used for arithmetic operations, operations, where in numpy you could perform cosine, sine, adjacent, all those SOHCAHTOA we did in school then, all those mathematical operations, exponential. So basically, if you want to design a calculator, you could use numpy to design it, because you could work with all the functions, all the libraries and functions in math with numpy library. Okay, so now over here we are using the function sine. So z equals to np.sine x. So it's going to give us the sine value for x, and x is 1, 3, 6, 8, 11. So the sine value of 1 is this, the sine value of 3 is this, the sine value of 6 is this, the sine value of 8 is this, the sine value of 8 is this, and the sine value of 11 is this last one. Okay, sorry, I didn't run it before. So this is 1, this is 3, this is 6, this is 8, and this is 11. Okay, so now what if we now want to plot a chart, that is, we want to see the flow of x and z. Okay, don't forget z is the sine value of x, while x is the value itself, that is the mean space between 1 to 11. Okay, now if we are to run this now, so now we're going to have this chart, that is plt dot. So if you want to plot something, you say plt dot plot x comma z. That is, the value of x is plotted against the value of z. Okay, so the value of x is on the x-axis, the value of z is on the y-axis. This is the y-axis, this is z-axis. Always note your horizontal and vertical. X is for horizontal, y is for vertical. Okay, so now let's try to plot x comma y. Here we plotted x comma z. Now let's plot x comma y. So x comma y is going to give us this line. Okay, now let's move on. We have s equals to np dot arrange. Now arrange will give us, we've talked about arrange in numpy. Okay, and it gives us an array range between 5 to 17 of step 2. Okay, so it's going to give us a value between 5 to 17, step 2. So just the way we'll select even numbers between 1 to 10. We select even numbers from 1 to 10 to be 2, 4, 6, 8, 10. Okay, so if you select even number, step 2 is even number. Okay, so just that way too. That's 5, 7, 9, 11, 13, 15. Okay, so now let's work with cos now. No, we've worked with sine, right? So now let's work with cos. So I equals to np dot cos x. We're still using the value of x, and x is what? X is this is x. So you say cos x, this is, so it's going to generate the cos value for each of those stuff. Okay, so now this is what we have in here. Now let's try to do a plot between x and s and I. That is this value of s, this one against this one. All right, so plt dot plot s comma I. Okay, now this g o dash dash, it means the style of the line. As you can see below, we have green. Okay, so we have 3 types of color. We have the RGB primary colors, that is the red, green, blue. So if I can change this to red, I can change this to blue, I can change this to blue. So let me change this to red, green, blue. So if I say plt dot plot s comma I, that's the value of s against the value of I. Okay, sorry. I think I have to run this from the beginning. The dimension, the value of the dimension differs. Okay. Now, yeah, I'm supposed to put 6, and yeah, I'm supposed to put 10. Okay. Okay. Now, the reason why it gave me error is because here the value count here must be the same as the value count here. That is, if here is 5 or 6 numbers. Now 5, that's 1, 2, 3, 4, sorry, 5, 6. So now this S is 6. This is 1, 2, 3, 4, 5, 6. That's complete. So the shape of the two values you're trying to plot must be of the same size. That is the same shape. Okay, note that S comma Z must be of the same size. Okay, that's why I kept the error there. So I was saying earlier that we have red, green, blue. So I could change it. So I've changed it to red. Okay. Now the O is the point of intercept. Okay, that's the point where X and Y, that is the one here and the one here, where they meet. Okay, so we could later on down the notebook, we'll be looking at more of it. But we have the three basic. We have the O. This is not 0. This is O plus asterisk. So I could decide to use asterisk. Okay, I could decide to use plus. I could decide to use plus. I could decide to use O. Okay, so now the last one here, that's this dash. It means straight line or broken line. So double of it is broken line. One of it is straight line. So the double of it is broken line. So if I run this, we're going to have a broken line. So plt.x label, that is, you're trying to label the x-axis. And you say plt.y label, you're labeling the y-axis. Then plt.title, you're giving it the title. You're giving the plot a title. Okay. Now, moving on, we have two ways to create a matplotlib. So the first way is the functional method, which we have been doing from the beginning. Okay? And the second way is the OOP method, that's the object-oriented method. Okay, now the functional method is same as what we've been doing above here. All this we've been doing are also called functional method. Okay, so functional method does taking plt.plot x comma y comma here you say blue, then the line, the intercept style is O. We could decide to change this to plus. Then the line, type of line, that's straight or double. So we could do, or we could put question mark here. It's going to be straight with dotted line, straight line with dots. Okay, so but we could have dot dot. We'll be looking at the design later. Huh? So we could have B plus dot dot dot. That is this intercept here is plus. I could change it to O. So it's going to back to color. Okay, so we've talked about plt.x label, plt.y label, plt.title. So this value here could be anything of our choice. Okay, the value here could be anything of our choice. Okay, now creating multi-plots on the same canvas. Now, this stuff on its own is called canvas. Each of this box, red box and blue box are called canvas. Okay, we could have empty canvas just like this. We could have empty canvas just like this. Okay, so now creating multiple plots on the same canvas. Now imagine this box. We want to split it into two, right? We want to divide this box into two. That is from this place down. Okay, 1 is divided into 2. How do you go about it? So that's where multi-plot on the same canvas comes in. So we have the first plot, we have the second plot. So for the first plot, which is this, you say PL to the subplot 1, 2, 1. Okay, and the second one, you say PL to the plot 1, 2, 2. Now the first one here, this one here, represent number of rows. Please don't forget the difference between rows and columns, or vertical and horizontal. So we have from this point here, and we go like this, it's called rows. While from this point to this point, down here is called column 1, while from this point to this point, down is called column 2. So now for column 1, so we just say PL to the subplot 1, that is the first box, number row. The number of rows is how many? 1. Then we'll say number of column 2, because we want column 1 and column 2. Then the plot number 1 plus number 1. So we could do the same thing, PL to the plot 1, 2, 2. That is the number of rows. When you say number of rows, what are they saying? That is how many boxes, like from this place to this place, from this edge to this edge, you go in this direction. It's just one box. Don't forget, I told us we have one box and we want to divide it into 2. So just one box, comma, number of column. So number of column is 2, same thing as this column 1 is column 2. Then plot number 2. We could have plot number 3, we could have so many as possible we want. Okay, so PL to the plot x comma y comma x, b means blue, r means red. Okay, so Matplotlib object-oriented method. Now, for this method is a bit tricky, but simple and straightforward. This means we will have to pay attention to the key things I'm going to underline. Okay, so now let's get started. Now they said, now that we have seen the basics, let's break it down with a more functional introduction of Matplotlib object-oriented APIs. Okay, so now using the second method is the OOP method. Now we are going to have something called, we're going to divide it into 2. That is the first and the second. So whenever you want to do OOP method of Matplotlib, the first thing to do is to do declaration. We could call this, that's the way, like if you understand programming, variable declaration. So we could declare this guy. So we could declare this guy. So first fig equals to PL to dot figure. Okay. This fig here could be any variable of your choice, but don't forget you could use it throughout. No one is going to penalize you because it's your code. Okay. So we say fig equals to PL to dot figure. This is the first line of code. Fig equals to PL to dot figure. Then second line of code is going to specify, that is, the subplot can be specified in 2 rows and column. Okay. So now let's try something else. So now the first thing is variable. That's the way I said this fig here, we could change it to something else that we don't want. It's not compulsory to be fig. So me, I'm going to just name my own TUN here. So if I say TUN equals to PLT, there's figure. So you are creating figure as an empty canvas. Okay. And when we say axis equals to tuner.add axis, okay, we already said TUN equals to PLT dot figure. Then now we are saying axis. Now, this axis is a keyword that's often used, either axis or AX. So a lot of people use axis for AX. Later on down the notebook, you'll see where we use AX. Okay. So now we say axis equals to TUN, that is what we call in here. We call it here dot hard axis 0.0, 0.1, 0.8, 0.2. Now this 0.0 represents the left, this represents the bottom, this represents the width, and this represents the height. Okay? And note that this axis they must range between 0 to 1. That is, you can have 0.0, 0.1, 0.2, 0.3, 0.4, 5, 6, 7, 8, 9. So you can have up to 0.9, but it must not exceed it. Okay? So now how do we now do the labeling? So now don't forget we've said TUN equals to PLT that figure. Now I'm saying axis equals to TUN, the axis. Now I'm saying axis, this axis. So it's like we are linked it to each other. At least you see inside this place, you see TUN, and inside this code, you see axis. So they are linked to each other. So axis does plot x comma y. You know, initially for the functional method, we just have to say plt dot plot, and you carry and you just start plotting and you have your result. But in this case, you have to say axis dot plot x comma y. And axis dot set x label. Can you see there's difference between the functional and the object oriented? So now you just say, notice the use of set underscore to begin words. So axis dot set x label. Here you could just say plt dot x label, plt dot y label. Okay, but in this case we are saying axis. In this case we are saying set x label. So whatever is there is what is going to display on your chart. So x label, axis of set title. So the title you could name it anything of your choice. Okay. So now we are going to swap. We've done this. We've plotted x comma y. Now we're going to swap. We're going to say y comma x. Just same thing. So we're going to say y comma x here. So TUN dot equals to PLT dot figure. Axis equals to TUN. Just add axis. Now the reason why we're adding this axis is to shaping this this chart or this plot. So now let me show something. We have height. Let me run this first. So we have height to be 0.2. So what if I increase my height to 0.9? Can you see it increases? The chart increases. So if I say 0.2, that's my width. Can you see the width has reduced to 0.2? So this allows us to, so I'm not going to put 0.6 here. Okay. So now we've done what is here is same thing as here. We're just swapping y comma x to x comma y. So when you do that, you're going to have axis dot plt, axis dot set, sorry, axis dot plot y comma x, axis dot set x label, axis dot set y label, and you have your result like this. Okay. So now let's try to create something that is a box inside another box to see how it works. Okay, this is using OOP method. So don't forget we talked about fig equals to PLT dot figure. Okay, now we're saying axis 1 equals to fig dot add axis. Now the main axis, can you see that the values here are different from the values here? This is the axis here are different from the axis here. That's due to the size of the box. Okay, so if you are going to work on this kind of thing, you have to know the value to put in to fit to the box. Okay, so the large figure part. Now let me scroll down so you could see. So this is our end game. This is the end game. This is what we're supposed to create. Okay, so large plot and small plot. So for the large plot, we are saying x1 dot plot x comma y. Then for the small plot, we say y comma x. So we're just trying to swap the value of x comma 1, y comma x, and see what it's going to give us. So it's just going to give us the opposite. If the line goes like this, Now the other line will come like this, more like a bracket. Okay, so same thing, S axis 2 equals to PLT dot Y comma X, then set label, set title. Okay, so now let's move to subplots. Now for subplots, how does subplots work? We've talked about multiple creating multi-plots on same canvas. Okay, so now same thing just applies to subplot. Subplot is like a sub division of the main plot. Okay, that is half of the plot. Okay, so now let's look at subplots. So for subplots, we say PLT the subplot object will act as a more automatic axis manager. Okay, so you say, so now in this case, we always say, initially we always say fig equals to PLT dot figure, right? But in this case, we are going to say fig comma axis equals to PLT dot subplot. Okay, now again we say axis dot plot. You are familiar with this. You are familiar with a set label, set y, set total, plot x, y. Okay, so now let's try to break this code one after the other. Let's try to break it down. Okay, so if you say fig equals to a fig comma axis equals to PLT the subplot. Okay, now n rows means number of rows, n columns mean number of columns. So we have like two columns here. This column 1, this column 2. Okay, number of rows, at least from here to here, is 1. Okay, so it's regarded as 1. So everything here is regarded as 1. Okay, so that's number of rows is 1, number of columns is 2. So in subplots, so now we're looking at dealing with each of the position of this subplot. Don't forget I said a subplot is like and half of the main plot. Okay, so now let's see this chart, this plot, sorry. So don't forget we've talked about fig comma axis equals to PL to the subplot. N rows, that's number of rows, that's 1. The number of columns is 3. Is 1, 2, 3. So how do we go about it? So 0 represents the first chart, 1 represents the second chart, and 2 represents the third chart. Okay, just like the way indexing works. Indexing starts from 0. Okay, so now axis of 0 dot plus x comma y, axis dot set a of 0 dot set axis first plot. Axis of 1 equals to PLT x, y comma x. That is axis of 1 set title. So 0, 1, 2. So this 0 represents the first plot, the 1 represents the second plot, and 2 represents the third plot. Okay. So now we could also iterate through this array by saying for x in ax, ax, ex. Now where is ax, ex? Ax, ex. So this is ax, ex. So for ax, don't forget I told us that ax, they use this in place of axis. So you mean something like ax or axis. Okay. So for ax in axis, that is ax dot plot y x comma y comma r, x comma set x label, set y label. So that's why we have this. Okay. So the reason why we have multiple lines, we have one line here and multiple lines, because this stuff is iterating through this code. So it has to look through the first one, the second one, and the third one. So there's already an occurrence of x comma y. That's why we have the line going up here and the line coming down. Now dealing with fixed size. Now dealing with fixed size. Now, initially when we are dealing with functional method, we say fig equals to plt.figure, right? Now, the fig size also is another way to represent the size of a chart. So if I say fig size of 8,2, that is, I'm saying 8 is the width, 2 is the height. So VDX equals to fig dot add axis, VDX dot plot x comma y. Okay, so you know what this is. Okay, I think okay. Okay, so I was having an error here. So what I did was I added the axis. So when I run this, I have the axis. So you could do something like 9. Can you see the height increased? The difference between this axis and this one is that this one is fixed. That is, once you do this, it's fixed, and but this one, once you change the value, okay, if I change this guy to 2, that's reduced, right? Or if I change this guy to 10, okay, or let me say 14, okay. So this guy, does the fixed size work in hand with the axis also? But the axis takes care of the 4 angles, that is the left, the right, the bottom, the height, and the width. But the fixed size just takes care of the width and the height. Okay. So now moving on, we have fig comma axis equals to plt dot subplot. Now when I run this, I'm going to have, I said number of rows, 2 rows. That's why you see we have 2 rows. That is the first chart. That's why we have the first chart here and the second chart. That's 2 rows. The number of columns, 1. That is just 1 column from the top here to the bottom, but it's divided. That's why we have, there's a difference between 2 rows. That's why I say you have to understand the difference between rows and columns. Rows is like this. So that's why we have to say rows, number of rows equals to 2. That is the first table, will be the first chart, the second chart, that's 2 rows. Now, columns, that's 1 column. That is from this place to this place is 1 column. So the simplest idea is just imagine this is a chart, a full chart. You just divide it into 2. That's number of 2 rows. Okay, divide a full table into 2, or you divide a loaf of bread into 2. That's to have definitely have 2 rows. Okay. So now the axis dot 0, that is axis of 0 represent this first chart, while axis dot 1 represent the second chart. That's why we have x comma y and y comma x. Now the plt dot tight layout is used to ensure that there is no overlapping of the distance. Now let's remove this guy and run it and see how it looks like. Can we see how it looks like? It's come tiny and not that visible. But when we put in this and run it, it becomes visible because it allows overlapping. And so now we could decide to save this chart by saying fig.save fig.save fig, then we give it any name of our choice. Now the DPI, don't forget the format. You could put it in JPEG, PNG, PDF, doc file. Either way you save it is fine. Okay, so if you come back to this place, that is your file, you could see here test.image. Once you open it, you have access to this. Okay, so now we have we have DPI. DPI has to do with the size of it. Okay, so you could play around with it. You could increase this or decrease it and save it with different this thing. Let me give us an example. I'll name this 2 and I'll give it 50, just 50. I'm going to run it. So when I run it, I come back here and find DP2. I'm going to find the chart. Can you see how tiny it is? Okay, good. So now moving on, we have fig equals to pl2.figure. Now, what method is this? This is the functional method. Okay, it's a functional method, but we are still adding the OOP method. So in general, you can just call it the OOP method. Okay, but this is actually the OOP method because you have set underscore x label, set underscore y label. Okay, so now if we run this, we're going to have this. Okay, so we print x and y. The reason why we have this is because we want to work with legend. Now, every graph we have as what they call legend. Now, if you don't know what legend is, this is what they call legend. Let me find it. So let me run there from the beginning. Now, can we see this stuff here? This line here is called a legend. Okay, so we've done it in such a way after plotting this guy. Okay, I'm very sure we understand to this point. So is this point where you see label equals to x squared and label equals to y squared? That's where it's called the legend. Now you could do ax dot legend look center. So we have different types of like different places you could put. I could decide to put this lower left. Let me try this and copy. Let me try to copy this for us to see. Okay. So I'll put this as a center left. So let's run this and see where it is. Can you see center left? So is at the center or is at the left of that's the left hand side. So you could put your legend anywhere of your choice. So now let's look at this. Now this is where I was saying we're going to work with this is very important aspect. So please pay attention. So now we'll be working with styling of charts. Okay. So now let me scroll down. Now this chart, as you can see here, is a very beautiful chart, but you could do it in such a way to be more beautiful. Okay, so now we understood this extent. Fig equals to pl2.figure, ax, or also called axis, but we're using ax here because the fig.add axis. The fig here is this fig. Don't forget. So if you change here to just fi or fg, then fg here, this place must be fg. Let me run this. Can you see no error? If I pull fig, I'm going to get an error. Okay, so just fg. So I'm going to run it again. So now we have some attributes. All these are called attributes. You know this aspect where we say ax.plot x, y. It has so many attributes. This place where we say ax, it has axs.plot. All these points where we say ax.plot, all these points, they have an attribute in them. Let's try to explore this one before going down. So if you do shift tab, okay, let me see what it has. Okay, x label, y label, data, plot. Yes, it has a lot of attributes. All right, so but let me not go into details in that. Let me just explain what each of these attributes are. So the first one is color. So we could have color, either brown. Let me change this to yellow. When I run this, I have yellow. Can you see the line changes to yellow? I can have red. Let me just change it to red. If you can spell out the color out. Okay. Now we have LW, which is the color width. As this is one we are now. LW is the color width. So you could do that how thick you want the thickness of the line. So I could change this to 5. So when I run this, can you see how bold it is? I could change this to 0. There's no line at all. So I'm just going to change back to 3. Okay. Now alpha has to do with visibility. That is how transparent you want it. So if I say 0.1, now you see how transparent it is. Okay, so I could do it. So if I start running from 3, it's transparent, seriously transparent. If I say 0 point something, 0.3, shade it transparent. Okay, so let me just put it back. Okay, so now LS has to do with the line, the shape of the line. So we could have double dash. Double dash means broken line, just the way we see we have broken line. One dash means straight line. So when I run this, I have a straight line. Or a semicolon. A semicolon like this gives us a dotted line. Okay. Or if you want a dot, a dash, or we have dot and dash, which gives a dash and a dot like that. So you could try this out on your own. Okay. Now let's talk about the next thing, which is the marker. Now the marker to mark out the point of the line, that is the point of intercept. So the point of intercept between this place is like 0 point something to this place, or 1 point something. If we are familiar with graph, okay, the point of intercept. So now this marker now has 3 types that we are familiar with. We have O, asterisk, and plus. So for asterisk, you could put asterisk here and run it. You have asterisk here, you have plus. So you have plus. So if you run plus, you have it there. Okay. The marker size is like the size of the marker, that is this plus or O. So let me just change this back to O. Not 0, O. Okay. The marker size, I didn't put anything. Let me change it back to 5. The marker size is reducing in size. So let me change it back to like 10. So the higher the number, the bigger the size of it. Now let's talk about marker face color. Now the marker face color is what you see, it's red inside. So let me change it to yellow. Okay. Then the marker edge width, that is this width you are seeing. Let's change it to 6. Okay. The marker edge color, marker edge width, marker edge color is green. So this color green you are seeing is marker edge. So let's change it to brown. Okay. So I could reduce it to 5 to 4. Just reduce. Okay. So these are the attributes of a plot. So you want to style your line, you could do more styling with it. So now let's just work with this one. Let me just show us an example. So as you can see here, we have various lines from red to green. So it's just showing us different colors and different style. So you could start with the first color, which is red. So from red, it moves from 0. That's line width from 0.5, 0.25 to 0.50 to 1.0 to 2. So what they did was they plotted x plus 1. So if x is 3, so 3 plus 1, if x is plus. So that's what makes the line from this aspect, from this thin aspect to this thick aspect of the line. That's what makes the line move from thin to thick. Okay. So same thing applies to the green. So the green also, they talked about the line types. That is, we have the dash, the semicolon, the double dash. Then the other one talks about the symbol marker. You could have plus, you could have O, you could have S, you could have 1. So for the S is going to be box. Let's try S here. For the marker, let's try S here. So if you put S here, it's going to be box. That's why we have a box here. Okay. Then we have, so we now combine everything together, marker size. Okay, so that's that about that. Now you could let's try this example on our own. For this one, we are using tuna. Instead of fig, we're using tuna. AX equals to PL to the subplot fig size 12,6. That is, the width and the height of this box is 12,6. That's the fixed size. Now AX dot plot X, Y, color red, line with 1, marker 0. So the red line, this first code right here, is for this red, while this other one is for the purple. Okay. So now moving on, we have plotting with an inbuilt data set. So now let's try. To plot with an inbuilt data set. So we've not talked about Seaborn yet, but we'll be looking at Seaborn after this. Library. So Seaborn has several inbuilt libraries, okay, that we'll work with. But first of all, we'll be looking at flight data sets. So for the flight data set, you just say this flight, you could name it any variable of your choice. So that's SNS. The library is called Seaborn, so that's why we say import Seaborn as SNS. But just note this: when we get to the library, you see how we work with it. So we just say SNS.load data set flight. Then when we print flight, we have this data set. So this is the data set for flights. We have the year, the month, and the passengers on board. Then we have another one called tips. Tips is another data set. If I run tips, this is a tips data set. This is an inbuilt data set. That is a follow com data set with Seaborn. Okay. Then when I talk about, so now let's try to plot the tips data set. Now we have total bills here, right? We have total bills. So that's what we're going to plot, just the total bill. We want to see the total bill for each of these based on the gender, the smoke, and everything for the entire data set. So we're going to say fig equals to plt.figure. The fig size is 8,9. That is, this entire box is 8,9. Okay. Then axis equals to fig.add axis. Now, this add axis, you are familiar with this add axis. That's the left, the bottom, the width, and the height. So now axis.plot df of total b. Hope you can remember this from pandas. We talked about this in pandas. That if you want to pick a column of a data set, you have to call in by the container. df is the container holding this entire data set. That's why we say df.total bills. Okay. So now you could say axis.set x label.set y label. Okay. So when we run this, we have this. So you could see how it moves up and down. So now let's talk about flight data set. So for the flight data set, we have this, and now let's plot this. Now, if you plot the file data set, we are familiar with what this first line of code. By now, we should be familiar with it. The second line of code, we should be familiar with it now. Now, ax.plot fg of year. Now, let's go back to this. Fg is the data set holding this entire data set. Then fg of year, we want to pick the year. So we say fg of year. I want to pick the passengers, and we say fg of passengers. Then all these color, line width, line style, marker size are called attributes. So all we just have to say is the color blue, line width 1, line style. As a line style is dash, we could do dotted. Let's run with dotted and see. So you can see dotted line, or we could run with semicolon. Let's run with semicolon. So semicolon will give you this. This one, let's try with S. Let's change this to S. It's going to give us box. Okay. So you could run with plus. Let's try with plus. Give us plus. So either way you do it is fine. You could just play around with it. So we are familiar with X label, set X label, set Y label. Now the plt.show it allows us to visualize. Now let me run this without plt.show. Can you see how not fitted it is? So plt.show allow the chart to be like more fitted. Okay. So now moving on to the other special plots. Now these ones are just there for us to see. We've talked about link space. The first code is what we're familiar with, the first and the second code. And this link space, we talked about giving us a number between 0 of 1 of size 100, okay, which is above that. So it's just going to give us x, np.sine x, r is red. So ax.plot. So it's just going to give us this wavelength. Okay, so we could check this out also. So we have legend blue, red, breeze, and rock. So all these are different lines. So you could explode. So we have the solid line, the solid line, that's the blue. Okay. So you could check the code. This is the code for it. Then we have the other one, which is the green line, the vert line. So you could check, you could also use color code. Can you see over here, they use blue, they use G. G means green, they use 0.5. I think that's a color code. This hexadecimal color code. Okay, so they gave it a title, they gave it a legend. Now the plt.legend look left, okay, talked about, I told you we could put it in different fields. So they put it at the lower left side. So they gave it X label and Y label. And Sine, sorry. Okay. So that's about everything. So we have error bar or error chart. So this one too moves in a wavelength format. If you want, you could do more read up on this. We have this histogram plot also. If you want, you could do more reading on all this. But I would advise that you familiarize or you check this this guide, that is the chart type. You go through them and see how you could apply them. Let's look for pi. At pi now, if you want to work with pi, you just know you have to say subplot ax.pi. Okay, so if you want to do a pie chart, to do ax.pi. If you want to do let's say violin, you just have to say ax.violin. Can you see? Okay, so you could copy each of this code and play around with them. If you have, let's say, scatter plot here, you just have to say it's ax.scatter x, y, then you pass in the necessary values. Okay, so that's all for Matplotlib. If you have any question, please let me know. Then we also have an exercise here for us to do. So please, let's try to do the exercise. And if you have any issue, please let me know. Thank you very much and see you in the next class.